All right, so continuing with our chapter one content, let's get a quick overview of what is actually in our food. What is a nutrient? What is this energy and how are we getting it? What are macronutrients and micronutrients, right? And we'll dive a lot deeper into each of these topics throughout the chapters of this textbook. But for now, just starting with this basic overview. So nutrients are the combination of organic and inorganic molecules that make up our food. So organic we can generally describe as a molecule that is mainly composed of the element carbon, so it has a carbon backbone. This is what makes up a majority of living things. Your body is mainly made up of organic molecules. And then inorganic molecules are things like metals and minerals, right? Like iron and magnesium and sodium. These are all inorganic. They aren't using carbon in their molecular structure. But all of this is important, whether it's organic or inorganic. It all contributes to your health and is all a nutrient in your food. And so we can generally put all of these nutrients into the categories of carbohydrates, or what we more commonly know as sugars, lipids, which we more commonly know as fats and oils, proteins, and then vitamins, minerals, and water. These are the main nutrients that make up your food. The energy of our food is what we typically represent as calories. But a single calorie is a very, very small amount of energy. And so what you're seeing on your nutrition facts panels, on your processed food boxes, these calories are actually kilocalories, which is 1,000 calories. And you don't necessarily need to know how this is measured, but just wanted to give you a bit of reference to where we get these numbers from. Essentially, these kilocalories, or how much energy is contained within a piece of food, this is determined by this controlled burning. Essentially, you put a gram of that food in this little cup and you put it into this big chamber called a bomb calorimeter. You set that piece of food on fire, and then you measure how much the water around it changes in temperature. And then we have an algorithm that determines from that change in temperature how much energy that food released, and boom, that gives us our calories, right? I'm not a physicist and could definitely have a better understanding of this. So if you're curious about how bomb calorimetry works, please feel free to look up a video on it. That's essentially it. We burn the food, we see how much that raises the temperature of the water around it, and that gives us our calorie number. Okay? And so with that understanding, we then can apply that based on how much of that food we're eating. And so we represent that by this energy density number. So how much energy is contained within 1 gram of that food. If you know that number and you know that you're eating 10 grams of that food, you just multiply your energy density by the amount of food. So we're going to get a lot of practice with this type of math, with applying this information. But essentially, we have determined that on average, carbohydrates provide 4 kilocalories per gram, lipids provide 9, and proteins provide 4. So for 1 gram of carbohydrate, you are providing your body with 4 kilocalories. So if you were to eat 100 grams of carbohydrate, that is supplying your body with 400 kilocalories. Right? That's the main idea. And so uh, applying this on a larger scale, looking at a whole meal, we can calculate energy density if we know the overall mass. So this breakfast on the left is 450 grams of food. This breakfast on the right is 144 grams of food. And if we also know how many calories each meal is giving us, which in this case it's the same, 500 calories from each, you just divide the amount of calories by the amount of grams, and that gives you the energy density. So go ahead and pause the video here and quickly do that calculation. So divide 500 by 450, divide 500 by 144, and that's going to give you your energy density. So pause. And hopefully from your calculations, you got a energy density of 1.1 kilocalorie per gram for this meal on the left, and an energy density of 3.5 kilocalories per gram for this meal on the right. And so that simply means that you can eat less food. So from this donut meal, it takes less of this donut to provide the same amount of calories as the meal on the left. And so this meal on the right, the donuts, is better for supplying energy, but this meal on the left is better for controlling your calories, essentially, right? You're eating more food, so you're going to be more full, but getting the same amount of calories. So there is a bit of balance between these concepts, determining in some cases it's good to get your quick energy with less food, and in a lot of cases it's going to be better to spread out those calories through lots of foods that you aren't over consuming. And then much later, we're going to go into nutrient density, which is a much more important factor here, where even though you had to eat a lot more of this food on the left to get the same amount of energy, you're getting a lot more nutrients from this meal compared to just your donuts. So here's another opportunity for practice with energy density. So same idea, take a second to do these calculations. You want to determine the overall mass, you want to determine the overall energy, and then you'll take the amount of energy and divide that by the mass. So for number one here, you would take 348 kilocalories and divide that by 100 grams, and that would give you your energy density for this meal. For number two, you're going to need to add up both sets of calories and add up both masses here, and then you'll need to divide those numbers, etc. So go ahead and pause and practice calculating here, and then I'll show you the answers on the next slide. Okay. So from this steak, we took 348 calories, divided that by 100 grams. That gave us an energy density of 3.48 kilocalories per gram. So every gram of this steak gave us 3.48 kilocalories. For this second meal here, an apple and banana, we had to add up our total calories, so 65 plus 105. So this meal gave us 170 calories. We had to add up our mass, so 125 plus 118. We had to eat 243 grams of apple and banana. And then when we divide those numbers together, this apple and banana together gave 0.7 kilocalories per gram. So every gram of apple and banana here gave us less than 1 calorie. And then finally, that 2 donut meal that we were showing earlier, essentially here, if you eat 75 grams of donut, that's going to give you 299 kilocalories. Since we're eating 2 donuts, we can just multiply each number by 2, and then 598 kilocalories divided by 150 grams of donut gives us 4 kilocalories per gram. So this is our most energy dense meal from these 3 options. All right. So I think I'll stop that here. I think that was a lot of information, and then I'll see you in the next one to talk about macronutrients and micronutrients.